I keep getting asked, what language should your kid learn to code? Or if you're a student who wants to make games, where do you begin? I'll walk you through the easiest tools for game development, from drag and drop to full scripting, and how each one builds your skills. This is not a comprehensive list at all, but there's enough variety here to give you loads of choices. I've been studying game development across platforms since I was 8. I'm 43 and love helping new creatives find their flow. I still don't have it down, but I've made a few partial games and I know a few languages pretty well, like JavaScript, Python, bit of Liberty Basic and Basic. I sidetracked a lot into theater writing, art direction, fiction writing, filmmaking on video, cartooning, and a bit of web development to pay the bills. You can learn just as much from my start stops. That will save you a lot of time. That's what I want for you. Part 1. Why coding matters for game development. All games run on code. Yes, even visual tools have logic behind them. If you want to be able to bring your ideas to life, say you're a keen artist, designer, storyteller, scriptwriter, and/or audio fanatic, and you've decided games or software is your chosen medium, or you have a specialty you want for your career focus, like level design, interior architecture, or 2D character concept art, you will want to learn to code at least enough to communicate your ideas via prototypes to, say, a coder who can scale your code. The thing is, when you get to Python or JavaScript, you will be able to build whole games yourself and you won't need to negotiate creative input from other people. You'll have full creative control. And if working with others feels like a good thing to you, you can look at indie developers whose vibe you love, like Wishfully or Triband, Cotton Game, Might and Delight, Giant Army, Supergiant, Megagon, Exosiphon, Hemisphere, Playdead, Morepork, or Rocketworks if you're in New Zealand, Devolver Digital, 22 Cans, Campo Santo, and the list goes on. But you may want to get some experience, like 2 to 3 years working for a smaller developer before applying to those mid to high level indies to get a better shot at actually getting hired. That's where networking helps. And build a portfolio website to show off your progression and start applying to those gigs, and or even turn pro. Maybe your dream is AAA. Hey, that's not impossible. In fact, those usually come with more benefits than indie, especially if you have a passport and are keen to travel or already live in a burgeoning metropolis. But it all starts with code. And the reason I'm trying to push being able to make games fast is something I found myself in my own journey, that without some kind of tangible success on your coding journey, e.g. making a game, you can really quickly lose motivation to learn to code well enough to make that dream game of yours. Learning to code is learning a language, and learning to build games is learning features of the language that function fit with your intended features, like ordering a meal in French versus having a fluent conversation in French. It's language and tools. Once you find the right workflow, you don't stop learning, but you can make games much faster. You don't need to master C++ or Unity to get started, or even at all. I remember the first time I got a character to move on screen. I was probably 8. Code wasn't boring, it was magic. By 11 I was tying sprites together to make them bigger, to access more detail in moving graphics. I got bored while building a boxing game, so I turned it into a game of Pong with the heads for balls. The heads were like 4 sprites tied together in a square. And I managed to get the room so that when a ball left the side of the screen, or the top of the screen, or the bottom of the screen, it reappeared smoothly moving in from the opposite side of the screen. Okay, part 2, the toolchain. 7 systems to try. The first system I want to introduce you to is actually 3 tools. Scratch, which runs over the top of JavaScript. Game Bender, which was hardware and software powered by Scratch, but was a bit expensive if you didn't get it through a school. and Makey, which is hardware hacking, but affordable and easy to learn. So Gamebender, if you've used Scratch before, imagine that, but with a turbo boost. Gamebender by Joy Labs, Jay Silver's company, is like Scratch on steroids. It was originally designed as a physical console where kids could literally bend and remix games live while playing them. Super interactive, super intuitive. It made coding feel even more than normal, like magic. But here's the twist, they actually scrapped the hardware launch back in 2019. Gamebender now exists only as a beta phase software platform. You can still explore it at gamebender.com, and it's definitely worth a look if you're into creative coding or teaching it. It's still based on Scratch, but adds a playful remix-oriented twist. As of now, it's still in beta and not widely supported, so it might be hard to find. And then there's Makey, also by Joy Labs, which brings physical invention into the mix. Think bananas as game controllers, cardboard as keys. It's simple circuitry plus Scratch-style logic. Great for kids and tinkerers. One of the cool things about Makey that I found is that if you are drawing with a pencil, you can turn that, because of the pencil lead still being on the page when you draw with a pencil, you can actually turn the pencil drawing into circuitry with a Makey. Together, these tools don't just teach coding, they teach creative thinking. The visual drag and drop style helps new coders see logic happen, which builds problem-solving instincts before you even get to syntax. Perfect for beginners, educators, and young game developers in the making. Now, what does drag and drop mean? So drag and drop refers to the way you interact with the computer. Languages lean more towards typing statements made up of strict format and styled pieces of language called features and functions and variables. I'll get more into that later. However, drag and drop makes the whole interaction process visual and almost physical, where you click on visual objects that represent pieces of code, like bits of a statement that you drag and drop into place and then stitch together to create statements that actually both make sense to you and the computer understands. In a perfect world, much of coding is fixing your statements so that you understand what they're doing, so you know they're doing what you want, and the computer understands what they say, it reacts the way you want it to. That's debugging code, which is a huge part of the learning process. Luckily, that's basically what forums are for. And the people there are real people who are masters of code who generously offer their time for free to people like you and me to help you understand your own code and get the results you want. A lot of the time when debugging, you'll learn what learning style works best for you. Some people really dig the forums and understanding what the kindness of strangers can offer beginner coders in finding out how the code works. Some people like to go back through the books or ebooks or online instructions, or W3 Schools is a really good one, especially for JavaScript, interactive learning modules. And read over how it really works as opposed to how you thought it worked. And remember what you're doing wrong. Again, other people prefer video tutorials like YouTube. I love YouTube for that. Finding your learning style is a big part of the process, and when you know that, you're halfway there. This is the best way to learn, by going through your training resources, trying to build something simple or a small version of your dream game. Then when you get stuck, usually because you're getting a bit ahead of what you do know, you start to debug, and that's when it really clicks and you start to understand how the code really works. It's a recursive process of this system that just scales in fun and potential for what you can create. Section 2, so toolset 2, logo and Roma, vintage turtle graphics. What was the first robot you ever programmed? Okay, we're going back a bit. It was probably a Roma from the 1990s. I went to my summer school program at the local computer shop. Now, this local computer shop is where we got our family computer, the Acorn Archimedes. The school had one as well. At the time, there were 3 real competitors. But I don't know how well the Archimedes was actually doing in the market. To me, it was a great system. It had really cool games and a decent variety, had programming and a few office programs. It's not great to emulate because it's still drag and drop and doing that with a console stick is awkward AF. But I really liked the car racing game Lotus Turbo Challenge 2 and the James Pond stuff. It was a bit like a souped up Amiga 500. But they did have a version that actually had an IBM PC processor chip, like the computer brain, in it. And it also had a Riscos, which is the Archimedes operating system, processor chip in it. So it was basically two computers in one. And I'm not talking about digital dual booting. I'm talking about actual two computers in one. It had two brains. So it was dual processors and dual operating systems because Archimedes ran its own operating system called Riscos. And it was a Windows style operating system rather than DOS style operating system. Anyway, let's get a bit away from the Roma. The Roma was about the same time. It was fascinating at the time. It was really just a robot turtle. You could program functions for directional sequences. Like you basically wrote simple code to tell it to go forwards, backwards, or turn however many degrees. Later on, I got into trying to cast lead miniatures. I didn't know how toxic lead was, but I knew it was dangerous. I just thought it was dangerous if you got someone because it would melt your skin, and that would be really painful. I didn't know about the toxicity of the gas, but I never actually got to the point of heating up the lead. So I had some lead, and I had my designs, and I had all that stuff, and I was still doing soldering. I didn't know how to weld or anything like that. I was trying to build a battle bot out of metal, but my design was really super detailed, and at that size, I didn't have the maneuverability skills at folding metal, and I didn't have most of the tools for that sort of stuff, so it was DOA. Logo I learned in junior high school. It's robot programming software. Really cool if you can find it. Just search Wikipedia or whatever for Logo, Logo. What to try after that with robots? I guess for me, I was looking at Mego, Maego, by Digigen. And it looks super awesome. It's a remote controlled car with the option of shooting it with an infrared laser gun. So you've got a moving target that reacts to you, but you can also program the car in a similar way to the Roma Turtle. So it's super fun and a really interesting way to level up coding with robots. It's a toy, but it's an educational one as well. Oh, super expensive. What does teaching a robot really teach us? Sequencing. How computer logic works, how to organize a sentence in a coding situation, how to deal with syntax, problem solving with logic scenarios, and ideating building of physical things, then applying your purpose-built code to that imagined scenario, especially with things like makey and 3D printing. If you could remix one of these, what would your custom robot do? Compete. I love battle bots, but even in non-violent situations, I find that robots competing or as tools for human user competitors is really interesting. It combines machine learning with scale versus time, so it's a really intense short sprint of machine learning, or when robots battle, it's more physical. But I just love to see how robots can be used to compete against one another. It's a great catalyst for problem solving. The third tool set is Liberty Basic and BBC Basic, retro syntax learning. These languages taught me the fundamentals: input, output, loops, and variables. Input is what you give the computer: keyboard, mouse, controller. Output is what it gives back: screen, sound, printer, etc. It's the core conversation between you and the machine. Loops is telling the computer to go back and repeat something until you stop it. Endlessly looping without a stop is basically how you break a system. Some old school viruses were literally just endless loops. Variables. Pieces of information that can change: numbers, text, or strings of characters that make your code dynamic. So a word is a string. So life is a string. Or Elfwood or sliders. They're all strings. You can get into more detail with what strings and variables are, but that's usually in the training materials that you'll find that stuff out, and it'll click at some point in your head, especially when you get to debugging. One quirk that stood out for me in BBC Basic, and even Liberty Basic if you wanted, line numbers made your code stick in memory. If you type print hello without a number, it would just run once and vanish. But if you typed the number 10 and then print hello on the same line, just 10 space print hello, the interpreter remembered that line as part of your program until you cleared memory or powered down. It wasn't the same as saving to disk. You still have to use the save command, but it gave you the sense of actually building a program line by line, because it remembers the line if you type a line number. Modern languages like Python ditched line numbers. They use indentation and brackets instead, which is more powerful but a different mindset. It's very retro, line numbers. Still, understanding those old habits make it easier to appreciate why coding feels the way it does today. If you want to get into like the retro stuff, a really good movie to watch is From Bedrooms to Billions, the first one by Nicola and Anthony Caulfield as Gracious Films. Section 4, the microbit, hands-on hardware logic. The microbit is not anything like BBC Basic, except that it's simple and built for beginners. It's like a Raspberry Pi, not as powerful but similar kinds of projects, and way easier to get into. It's as simple as a makey-makey. You can do all sorts of programmable hardware electronics. It supports drag and drop block coding like Scratch or MicroPython, a lightweight version of Python that's perfect for beginners. Definitely worth checking out at this stage of the experiment. Builds simple games with real sensors or buttons. Teaches physical computing fundamentals, second introduction to actual code. Following basic, first introduction to modern code. 5 is the fifth toolset, Pico-8. The Pico-8 has incredibly simple structure. Each part of the editor serves a purpose. There's a coding screen or run mode, a sprite editor for pixel art, a map editor to lay out levels, and 2 audio tools, one for sound effects and one for music. You handle logic like collision yourself in the code, which is part of what makes it so powerful and flexible. It's super minimalist. The Pico-8 platform has so much going for it. If you make a game, you can distribute it via their main platform, or you can even put it on Steam as is and make money. Pico-8 isn't just for prototypes. You can make whole indie games. There are tons on there and really cool games. Some people buy a portable EMU console that sort of looks like a Game Boy just to play Pico-8 games, and they load it up with Pico-8 games. You can get like 50 Pico-8 games on it. I'm saying 50 because I don't know how many Pico-8 games there are, but I think it's in the hundreds. It's Lua based, so it starts teaching syntax while keeping the fun front and center. Toolset 6, RPG Maker, the everything engine. Easy to read and write, huge for tools and scripts and games. Can be used also to make machinima. Now machinima is movies that you make using game engine software, like game development software. Red versus Blue was created via, there was a glitch in Halo, and people have like screen captured the glitch and then used video editing tools. This is my guess of how they did it. Use video editing tools to cut together the movements and then just put voiceover dialogue over top. That's sort of how they say Red versus Blue was made. But there are other ways to make machinima. Just use a mod engine or, for me, RPG Maker and screen capture. That's what I want to do. That's why I've been learning RPG Maker with YouTube tutorials. I used ChatGPT to put together. I asked it to put together a lesson plan, and I told it what I wanted to learn, and what mechanics I wanted to learn, what tools I wanted to learn, and what was important to me, and I said put together a 12-month lesson plan, and it did. And then I took that 12-month lesson plan and I used it to queue up my YouTube tutorials. I just search for a YouTube tutorial based on the topic that I want to learn that day. So I do a 5 to 10 minute video every day on RPG Maker or Game Maker. Because I've got a Game Maker project, it's a football game that happens in the sewers, mixed with a roguelike in semi 3D, but the roguelike is in 2D. Okay, toolset 7, JavaScript. The web is a game engine. Power behind browser games, core to any interactive website, skill transfer across industries. JavaScript is potentially the easiest language to learn, in my opinion. It's also the most logical and rational syntax for custom problem solving and code solutions. Like how the system structures sentences makes more sense than some other languages. It's easy to pick up and it's faster to learn. It's also not just browser games that you can create. You can also create websites and web software. And some game engines actually have JavaScript running underneath, like for example Scratch. So that means that you can use these game engines as they're intended, or you can get under the hood because you know a bit of JavaScript. And you can remix the code, alter the code to get it to more leaning towards what you want it to do. You can mess with it if you know code. So yeah, that's another reason you should learn to code. Okay, part 3. We've done all the toolkits. That's 7. So part 3 is why you should try them all. Sampling different languages builds fluency, not confusion. It helps you find what clicks with your brain style. Each project becomes part of a personal portfolio. Understand syntax differences and similarities. Different languages teach you different things, and if you want to level up, you're going to have to change languages at some point. I don't advise starting with a difficult, i.e. a powerful, language. Real-world prep. Build a site, show off your projects. This is what gets you into indie teams or professional gigs. Why you should try them all. Sampling different platforms teaches flexibility, which is both future-proofing for your career and building a well-rounded intelligence, a huge asset in creative tech fields. Each platform forces you to think differently. Scratch makes you visualize logic. RPG Maker helps you manage events and story systems. Robot programming and hardware hacking teaches you real-world problem solving and how to apply code to business or current solutions. Pico-8 drills you in raw code and tiny design, and JavaScript connects it all to the wider web. By bouncing between them, you're not confusing yourself, you're strengthening your ability to adapt, to problem solve in new environments. That's exactly what makes a great game developer, and honestly what makes a strong creative thinker in any digital career. Plus, every experiment you finish becomes another piece in your portfolio, another story you can show to future collaborators or employers. Okay, the recap. Have fun, that's the key to high achievement in your learning journey, and find your specialist passion or become a multidisciplinary superstar. Start simple, explore, build a site, apply for small teams. That's my video. Please like if you like, and subscribe if you want to see more of my videos. Drop questions in the comments and I'll try to get back to you. Check the links in the description for the tools and resources. Thanks very much. Bye.